Would you like to see how stone-ground flour was made in the 19th century? I'm Joe Himmelly, and today I'm at the Peirce Mill in Washington, D.C. Grain would be brought into the first floor and deposited into the receiving hopper right here. It would flow down this wooden chute into the basement, where the grain would be scooped up by the elevator and carried to the attic. If you open the access panel, you can see there's a belt with little cups on it. The cups would be used to bring grain from one level to another in the mill. In the attic, the grain would be sent through a tumbling grain cleaner. After being cleaned, the grain would travel from the attic to the second floor, stopping for a layover in storage bins, before being dropped into a second hopper above the grindstone on the first floor. Grain goes through the opening, which can be opened and closed with this device. It then goes through the hole in the runner stone, which is the top stone of the mill. The grain is milled between the runner stone and the bed stone, which is underneath. The coarseness of the flour is controlled by raising and lowering the runner stone using this control. Here you can see the grooves, called furrows, where the flour is pushed out and collected. This model shows how the furrows grind and push the grain down to the edges of the stones. The round wooden piece, called the vat, collects the flour to be sent down a chute for cooling and drying. If you look here, you'll see that there's a chute that brings the freshly milled flour into the hopper. When the flour arrives, it's both hot and wet. These gears are connected to the shaft, which rotates the rake at the bottom to both cool and dry the flour. The flour would come down this chute, and this wheel would be turned to power the sifter. Here's what the sifter looks like on the inside. It's mounted at an angle with the finest mesh at the top. As it turns, the fine-grained flour falls through the mesh. Further down, the mesh is wider and the rougher flour falls out here. Underneath the sifter, you can see where the flour is chuted down to the next level. Getting the flour into the barrels is very difficult. It would come down out of this chute here. To make sure that the flour didn't spread all over the place, they would put these extensions onto it. And you'll notice that there's a little hole at the end of the extension. And then there are pins here that would be taken out to put the extension into the chute. On the main level, you can see that there are levers and there are pulleys that control the flow of grain throughout the mill. Here you can see there's a wooden board with a hole in it. And if you pull it across, it opens the chute so grain can flow through. And if you push it the other way, it closes. There's something funny about how this building is built. This mill has what's called a Hurst frame that you see here, and it's fully separated from the walls of the mill. A Hurst frame is what supports all of the machinery of the mill. When in operation, the mill creates a lot of vibration and movement in the frame supporting it. If the mill equipment were directly connected to the structure of the building, it would literally shake and twist the building, and the structure would deteriorate very quickly. So the machinery is isolated by using a frame built inside the actual structure of the building. All of the outside walls you see are not actually used to support the mill equipment. If you look at the wall, it's stone at the bottom, but at the gable you'll see that it's wood. On this side, the wall is stone all the way up, including the gable. There's a lot of heavy equipment on every level of this mill. If something on the top floor needed to be replaced, it would be cumbersome or impossible to move it using the narrow staircase. It's far easier to have the piece lifted in or out on a hoist, and that's why on one side it's made of wood, which can be taken down to move the equipment in and out and then replace the wall. Up in the attic, you can see the underside of the roof line, and normally there would be what's called a ridge beam, which runs from one end of the gable all the way across to the other. But here they don't have that. Here, instead of a ridge beam for support, you'll see that the rafters stand on their own. They're assembled using a half-lap joint held together with a trunnel. A trunnel is a wooden peg that is inserted through the holes drilled between the half-lap joints on the beams.